Well, for everybody who's here, Mike will be giving the presentation. I will be moderating the chat. So if you have questions during the presentation, go ahead and pop them into the chat. And at the end of the presentation, we'll go ahead and review those questions and then respond to them. So just drop your note in there and we'll do that at the very end of the presentation. And if you have questions about credits, Taylor Gernhardt is our administrator for those. We'll collect the attendance at the end and then, make sure that everybody who can provide us with an AIA number and or who wants certificates, we'll get all that stuff organized for you so we can submit it to AIA. Okay, one more minute here and we'll get started. Okay, we're at 5 minutes after the hour. Let's go ahead and get started. Good morning, everybody. My name is Steve Sorich. I'm PAC International Sales Director. With me today is our INC board certified acoustician, Mike Rayleigh. Mike Rayleigh is going to present design details for good acoustics. This is part 1, referring to walls. And go ahead, Mike, take it away.
All right, thanks, Steve, and thank you everybody for joining us. So today I'm going to talk about design details for walls. So this is kind of digging into some of the nitty-gritty of how we make, acoustical wall assembly actually, achieve the STC rating that we think it should achieve. So let's go ahead and kind of get into it. And like Steve said, if you have any questions, go ahead, throw them up in the Q&A. Hopefully we'll have some time at the end to address some of those questions. And if there's anything that we can't get to, give me an email and I can respond to you an email afterwards. So, all right, so let's get going. So first off, when we're thinking about walls and we're thinking about meeting, a specification, right? So like say you've got a code requirement, multifamily code requirement says, your walls need to be STC 50 or something like that. Or maybe you've got, the FGI guidelines for hospitals or, guidelines for schools, any of these kinds of things, right? They'll often have sort of like STC requirements, minimums for, the STC rating of a wall. And STC, just for some context, being the sound transmission class, it's a measurement of how much like the wall reduces sound transmission from one side to the other. So the higher the STC rating, the more sound transmission or noise reduction you get from one side of the wall to the other. So oftentimes, as acousticians or as architects, designers, whatever, we'll say, okay, hey, we have this STC 50 minimum by code for multifamily, for instance. So let's go kind of look through different, databases, maybe the Gypsum Association's Fire and Sound Design Manual. We'll go look at different manufacturers' websites, these different kinds of things, and find a wall design that, fits with kind of the type of structure that we're building and these kinds of things, other parameters that we have for our project, and also is at least an STC 50. And then we pick that wall, put it into our drawings, and we're good, right? Well, not really, because the way that wall is tested is it's tested in a lab, tested in an acoustics lab like this one right here. So this is an opening in an acoustics lab. And when we test it in a lab, it's a laboratory environment. It is a controlled environment. And really what we're trying to test is just the sound going through the wall itself. And we build the wall. There's no penetrations. There's no holes, right? There's none of these kinds of things. The perimeter of it is sealed really well, often with like big, heavy mastic tape and putty and these kinds of things, right? Not just a little bead of acoustical sealant. There's nothing mounted on the wall. It's this sort of idealized conditions because all we're trying to test is just that wall assembly. But in the real world, of course, we don't have that idealized condition. We have all these different things mounted on the walls. We have things in the walls, like electrical outlets and switches, these kinds of things. And, we've got hanging cabinets or decorative panels, TVs, all these different things mounted to the walls. And so we have to deal with all of these because these things are all potential weak spots in our wall that keep us from getting to that level of performance that we actually see from the laboratory test. So as we think about this, sound transmission from one side of the wall to the other, we've got our speakers over here on the left-hand side and, somebody, trying to like, quietly read a book, right? And focus, right? So We have our source on the left side and our receiver on the right side. And we think about the sound transmission through, right? So we have our sound source, we have the sound, just air pressure fluctuations hitting the wall on one side, and then that gets transmitted through the wall to the other side. And we can kind of think about this in sort of two main sort of transmission paths or types of transmission. So one of those would be the structural path. So that's really sort of all of our rigid connections, right? That would be drywall to stud to resilient channel here to drywall. And then we have the cavity path. So in this case, it would be, drywall to this air cavity where we've got insulation and then drywall on the other side. So we have the sound that's transmitted through both of those paths. And obviously there's multiple versions of these different paths, but those two kind of broad categories. And then the sum of all of that is the transmitted sound that we get to the other side. So sometimes if we put something like an electrical outlet, for instance, like this little blue blocks down at the bottom, that will typically affect the cavity path, right? So we'll have this cavity path coming through, and because we've got this gap in our drywall by this little like plastic electrical box, probably has some holes in it and stuff too, right? We've affected that cavity path, and so more sound can be transmitted through there. We get more sound transmission through this one path, and then our total transmitted sound is higher. Or maybe we have something that affects the structural path. So say we've got a cabinet, the wall elsewhere has resilient channel, but in this case, we've got a 1/2-inch OSB or plywood as a backer for that cabinet so we don't crush the resilient channel in the drywall when the cabinets are screwed to the studs. Right, so in this case, we've increased the structural path because now we've got a rigid connection from drywall to stud to plywood to drywall and then through our cabinets. So that increases the structural path and increases our total transmitted sound. So we need to think about these two kinds of things, and that's kind of, I'll use that as a way as we kind of go through and talk about these details. So I always like to try and think of like sort of other analogies, other ways of thinking about things, things that are maybe more relatable to folks. And so in this case, I think there's some analogies that could be helpful in building science that are maybe something that, a lot of architects might be more used to thinking about. So you can think about these kind of things in terms of air barriers and thermal bridges. So if we're thinking about a wall, right, and we're thinking about the thermal insulation value of that wall, say we've got just like a stud wall, and it's a 6-inch stud maybe, and we've got R19 insulation in the stud cavities. Well, R19 is the value of the insulation in those cavities, but that's not the overall insulation value of the wall necessarily, because every time we've got a stud, we've got this thermal bridge that's going to be a more efficient transmitter of heat from one side of the wall to the other. So the overall R value of the wall, or I think U value is the other one, right? But the overall insulated value of the wall is actually lower than just the insulation itself because you have these connections. And so to try and improve the overall thermal insulation of the wall, we try and minimize those connections. So we might go from having our stud space 16 inches on center to 24 inches on center because we have fewer thermal bridges. And we might also use some sort of like thermal decoupler. Sometimes on exteriors of buildings, they'll do rain screens, and instead of just using a little like metal Z clip to hold that, you'll have one with a little rubber isolator on it or something like that. You'll have something just to as a thermal break, right? And so in acoustics, we do the same sort of thing, right? For this structural path, we try and minimize the number of like sort of rigid structural connections from one side of the wall to the other. And if we do sort of have to have a structural connection, then we'll try and do something that provides some acoustic isolation, like resilient channel or something like that, right? Or sound isolation clips, these different kinds of things. So that's sort of our structural path analogy. And then for our cavity path analogy, you can think about a continuous air barrier, right? And so, the way that sound gets transmitted from one side of the wall to the other is through the air. Sound is, air pressure fluctuations. And so we want to make sure we don't have any holes or gaps that allow that air to easily pass, those air pressure fluctuations to easily pass from one side to the other. And when you're thinking about an air barrier for your building envelope, you're trying to reduce the number of air changes per hour, these kinds of things. It's it's not enough to simply specify and select some air barrier material and say, hey, put this up and you're done. No, you have to pay attention to all of these little details. Anytime there's a penetration for something like a hose bib or something like that, or you have sort of discontinuities where you transition from your wall to your roof or your wall down at your base plate, all of these little gaps and corners and cracks and crevices and things you have to pay attention to and figure out how to address those. Same sort of thing for acoustics. We have sort of our mass layer, which is typically like our drywall. You can kind of think about that as like our air barrier or our membrane. And anytime we have some sort of penetration in it or we have some change in it, that's a little area of a detail that we need to pay attention to. And those are the things that we're going to think about here. But first, a little bit more context. So how much do these little gaps in structural connections matter? So I just put together this morning sort of an illustrative example as I was thinking about this. So let's say we've got a wall, 8 foot tall, 12 foot wide, maybe typical like, apartment bedroom wall or something like that, right? In this case, I picked a double stud wall, 2x4 wood studs, 2 totally separate framed walls with a 1-inch air gap in between, 2 layers of drywall on one side, 1 on the other. STC 62 was the test report that I pulled. But what happens if we put just a 1-inch by 1-inch hole in that wall? What happens to our STC rating? So I ran it, did a composite STC calculation, goes down to an STC 41. So we lost 21 points. And we went from 12 points above like the multifamily code minimum of STC 50 to 9 points below it. Just a 1-inch by 1-inch hole. And by the way, in terms of the total area, that hole is 0.007% of the total wall area. So it doesn't take much to have a huge impact on this. And, I worked as an acoustical consultant for many years, and, there were times I would get brought in because, some office space had, 2 conference rooms next to each other or something like that, right? And they were, hearing conversations back and forth between them, or just they didn't get the level of sound isolation that they wanted. And I'd go in and do some tests and some investigatory things, and it might be that they just hadn't sealed the drywall to the floor at the bottom. So there's this little gap running along the bottom. And they had, some, vinyl base molding or something like that that even covered that up. There was no obvious gap, but you could hear the sound coming through there. And if you went and took a business card or something, then you could like slide it underneath there. So again, it does not take much. It doesn't take a big gap to really have a big impact on the acoustical performance of your wall assembly. So all of these little details are really important. So let's get into the details now. So I've kind of broken these up in terms of these different categories. And really in all of these, the cavity path and the structural path matter. You need to always be thinking about both of those, but I've kind of lumped these together in these different categories, kind of based on which one is maybe most prominent to think about for these. Although as I was going through this morning, there was one that I was like, I think I would change that now. So, again, these are kind of the more prominent ones that you think about, but you always need to be thinking about both of these path types. All right, so first let's talk about the cavity path here. So the first example we'll give is electrical boxes, something that's in pretty much every wall, something that we have to deal with a lot. So in all of these examples that I give in here, if at all possible, where I have like real acoustical test data for this, I've tried to put that in here and give the reference of where it came from if it's not a pack test. So in this case, this comes from NRC, the National Research Council of Canada, Canada's government acoustics test lab. It has done a whole bunch of acoustics research looking into details like this over the years. So here we have a 2x4 wood stud wall with resilient channel, a couple layers of drywall on one side, 1 layer on the other side. This wall starts out as an STC 55. If you put into it back-to-back electrical boxes, the rating goes down to STC 50. Now, that still meets your code minimum, but that is not taking into account any other gaps and also assuming that the resilient channel is installed perfectly and all these kinds of things, right? So for that second wall from the left, odds are, built that in the real world, it's not going to actually meet the code minimums. So there's a lot of risk associated with that wall, right? Just because we have these 2 back-to-back outlets. So then the rest of the walls show different ways of dealing with this, right? So this is this cavity path, right? So we need to figure out some way to address that cavity path. So one way of doing that is to just sort of increase that path or put some barrier in the path between the 2 outlets. And that's what you get from the 3 walls on the right. So we've just, offset these electrical outlet boxes further away from each other. And that gets the STC rating up to STC 54, so pretty close to the base wall. but trying to coordinate that on a project and make sure that everywhere you have these outlets, they're separated and all these kinds of things becomes a lot more challenging. It's just hard to do. Um, and so the way we typically address this is we put some sort of mass material either on the inside or the outside of the box. And so that increases the mass of the box, which reduces the sound transmission and also helps seal all of the holes. And typically what we'll use is a putty pad. And typically those putty pads are also fire rated and often required for fire. And oftentimes our acoustical partitions are also fire rated partitions. So, using a putty pad is kind of doing double duty, both for fire and smoke and acoustics. So that's kind of the thing, and that's an easy thing to sort of specify. And you can see just putting that putty pad on both electrical boxes brings the wall back up to the STC 55 rating. So a pretty straightforward thing to address there. Another question that comes up with this oftentimes is if you're using clips, sound isolation clips and hatch channel, they move the drywall further away from the studs. So then you have this bigger gap. And we'll be asked like, okay, how do I, get my electrical box to the actual face of the drywall? So there's electrical box extension rings. They come in a bunch of different depths. These are, you can go find them even on Home Depot, but electrical supply house, places like that should have these. So it's just an extension ring that mounts to the face of the electrical box. And we'll bring it out flush with the face of the drywall. And then you want to put your putty pad all the way around that to seal all of that. So that's all taking care of your sort of cavity path, making sure you don't have any gaps. But you also want to make sure that you don't create a structural path with these electrical boxes, right? So the clips and the hat channel are there, or a resilient channel or whatever is there to isolate this drywall from the stud, so we don't have sort of a rigid connection there. So when you have your electrical box go to your drywall, you want to make sure that there is a gap between the electrical box and the drywall. It seems sort of counterproductive for the cavity path, but then you seal that gap with things that are flexible that won't transmit that sound energy from the electrical box to the drywall or the other way around. And so the putty pads and then like the acoustical sealant that we use both remain flexible so they won't transmit that acoustic energy. All right, so another thing, where we sort of intentionally put a gap in our wall is control joints, right? So if we have a long expanse of drywall, so maybe a corridor wall in an apartment building or a hotel or something like that, every 30 feet or kind of there's some different parameters that affect this, but oftentimes it's sort of every 30 feet or something we'll need a control joint, and that's just to allow for kind of expansion and contraction in the drywall and the framing that it's attached to. So we'll put a joint in, but with that control joint is just a gap in the drywall to give it that room for expansion and contraction. But of course, now we've put a big slot gap down our wall. So here's the way that you can address this, and these are based off of some different gypsum association file numbers. You can see those down there on the bottom left for both a 1 hour and a 2 hour rated version of this. And really, you just need some gypsum board there that's attached to the stud that provides some backing to that gap. And then you use acoustical and fire rated sealant to seal those gaps. And then you would often maybe put like sort of a plastic control joint trim piece over this or something like that. But you want to make sure that this gyp that's on the stud, again, we're trying to seal a cavity path, but we want to make sure that we don't create a rigid structural path here. So there needs to be a very slight gap between the drywall, like on the face of the wall, and the drywall that's there on that stud. So there's not actually a rigid connection between them. So you need to pay attention to that little detail. But by doing that, you seal that potential path there. All right, so now let's talk about some structural paths. All right, so the first one is mounting cabinets and other heavy static loads to a wall. So in these cases, say you've got a typical kind of like resilient channel demising wall. And if you're going to mount cabinets to it, the typical way of doing this is putting, using 1/2 inch OSB or plywood, because the resilient channel creates like a 1/2 inch standoff from the studs. So you'll put half-inch OSB or plywood there, like either between, or I've seen it sometimes in place of the resilient channel, like where the cabinets are going to be mounted. And the contractors will put that there because when the cabinets are installed, they're typically screwed through the drywall and into the studs. And if you didn't have this spacer there, then they would screw them in, and as they're pulling them in tight to the studs, you'd start to, crush that gap, where the resilient channel is. So they put this in basically just like a spacer. But what it does is it creates a rigid structural path, right? You've got drywall, stud, plywood, drywall, cabinet. And so you can see here, base wall STC 54 from this test series. And then when we mounted the cabinets on it, kind of the standard way, right? I went down to an STC 46. So we lost 8 points. And more importantly, we went from a wall that was comfortably above code to a wall that's well below the code minimum of STC 50. So how do you do that? Well, you need to maintain that structural isolation. So you need to have something that has some resilience in it, where that cabinet mount is. So you can use an acoustically isolated backer. This is something that holds like a 2x4 or a 2x6 there so that you have a sort of a solid wood structure to screw your cabinets to, but there's acoustic isolation between that blocking and your studs. So it's a little metal bracket with some rubber isolators in there. So you maintain this decoupling and therefore maintain the acoustical rating of your wall. Similar sort of thing if you're using clips and hat channel, right? The point of the clips and hat channel is to acoustically isolate, to decouple your drywall from the studs so you get less acoustical transmission through that structural path. But again, if you're mounting cabinets, you need to have something rigid to mount those cabinets to. And typically with sound isolation clips, the hat channel that you're using is a 25 gauge or like an 18 mil hat channel, which often isn't enough to really support the cabinets and take those screws well. So we need something more rigid to do that. So there's acoustically isolated backers specifically for use with sound isolation clips that give you a much more rigid structure. You can usually use like a steel track. You can use heavy gauge steel track that you can mount your cabinets to, but they still maintain your acoustic isolation. And you can see here we've got test data for this base wall in STC 54, and with the cabinets and the backers on there, the acoustically isolated backers, it was an STC 53. And a 1 point variation is not noticeable, and it's within test variation. So essentially the acoustical performance was the same. So this is just something you need to think about, like, okay, I've got this demising wall, this acoustical partition, between these two, hotel rooms or these two apartments or classrooms or offices, whatever it may be. But like, what's going to go on that wall? Do I have electrical boxes? Well, then I need to address those. Am I going to mount anything heavy to that wall, whether it's cabinets or a TV or it's a headboard in a hotel room, these kinds of things. Like whatever you're going to do to that wall, you need to make sure that you've taken care of those details. And this is one of those. Similarly, we've got grab bars and handrails. Same basic concept as the cabinets, just maybe spaced further apart. And with these, you also need to make sure that you're paying attention to the required sort of load capacities for these. For handrails, I think it's a 200-pound load at a connection point in any direction, up, down, out, whatever it may be. And I think for grab bars, it's 250 pounds. I might be slightly off in those or whatever, but it's, there's these specific things. So you need to make sure that whatever you're mounting it to gives you that acoustic isolation, but also can take those loads. And so there are products out there that allow you to do that. So same sort of thing here, right? You got to think about it with resilient channel. You got to think about it with sound isolation clips too. All right, so another thing is deflection heads. And this is actually the one that I said this morning. I was looking through this and I was like, I should probably put this into the section that's like cavity path and structural path. But so this is really sort of like an intersection thing. And so here where we have an intersection between, a wall and a floor ceiling assembly, we need to consider a number of different paths. One is just the path directly through the wall, right? And that's what just like the S2C rating of the wall itself does, plus some of these other details for, electrical boxes, mounting cabinets, these kinds of things. We also need to look at the path kind of through the gap at that intersection between the wall and the floor ceiling structure. But then we also need to think about this path like from the floor ceiling structure down into the wall. And say, we've got a continuous concrete slab or maybe a continuous like CLT, like mass timber panel, right? And as people are walking on that, right, we've got this impact sound, this impact energy that's in this structural element up above. And if we have a rigid connection between our wall and that floor ceiling assembly, that impact sound that's in the floor up here will get transmitted into this wall. And if we have something really rigid like concrete and then steel studs, and we have a very rigid connection between those, a lot of that energy can get through that. And you'd be surprised how much like of this sound can get transmitted through a building. There was a project I did as an acoustical consultant that was out in it was a medical, I don't think it was a hospital, maybe it was a medical office building out in Astoria, Oregon. And they had an MRI on the second floor of this like 2-story medical office building. And when they would run a scan, like MRIs actually produce a fair amount of noise, all kinds of strange whoops and beeps and different things as they're running a scan. And when they would run this MRI, everybody in the building could hear it. And it was a steel and concrete structure. And the MRI was not isolated from the structure. And so once that energy got into it, you could hear it everywhere. And there was an unfinished space like in the opposite corner of the building. So it was the other side of the building. It was on the ground floor. The MRI was on the second floor. And if you were in that room, it was just ringing. All the steel beams and the concrete was exposed. And like I think you could even feel the vibrations sometimes in a beam. And it was just, it was like you were in the room with the MRI, but we were on the completely opposite side of the building because concrete and steel are really efficient transmitters of sound. So you have this kind of rigid connection here. How do you create some isolation for this path? You can see the arrow coming down there. So if you've got a deflection head, a deflection head is a bit of a decoupler already, right? Because you don't have, it's supposed to allow movement. And some acousticians will use, a slotted deflection head, slotted track as acoustic isolation at this kind of like wall ceiling intersection. I don't know that I've actually seen real test data on this, and this is a difficult junction to test. That's why I don't have acoustical test data for this. But sometimes just that deflection track alone can be enough. But if you want to go doing more because you're going for very high levels of sound isolation, excuse me, then you can use an isolated track. So you use an acoustic isolator. It's usually a rubber isolator that's there at that track. And so then you create this, this rubber isolation between your ceiling assembly and your wall assembly. So you sort of reduce that particular transmission path. But you need to make sure that you're paying attention again to a cavity path. So we'll typically have fiberglass or mineral wool, sometimes for fire, in the gap created between the floor and the track that's created by that isolator. You'll have drywall that comes down the sides that allows to like kind of move side by side. And if you're using clips, sound isolation clips and hat channel on your wall to get your acoustical performance through your wall, this deflection track needs to have this little bit that bobs over to hold the drywall out at the right depth for those clips and things. So there's a lot of like complicated details in here, but there are some UL fire rated head of wall details for this. There's special deflection track that you can find for all of these things. So you gotta dig through these details, but all the parts and pieces are there to kind of put this together and make sure that you're addressing fire and acoustics and deflection and all of these different elements that come together in these kinds of intersections. All right, so here's another one. So this is a furred walls, and again, we're looking at reducing structural paths. So this kind of a thing might come into play, like for the CMU block wall over there on the left, like say you've got an emergency generator. A lot of the pretty much every apartment building that I worked on as a consultant here in Portland would have an emergency generator. A lot of times those were inside the buildings to help meet, the city noise code for exterior noise at the property line. So you have your generator inside the building, and often, for fire and acoustics, it's then, basically like a concrete, CMU box. But then sometimes there was a unit on the other side of that wall And sure, it's an emergency generator, so typically it only comes on in an emergency when the power's out, those kinds of things. But they also have to test it on, I think, a monthly basis. And so, it might come on while you're sleeping in that day because you took the day off or whatever it is. So we need better sound isolation there. And also, you just want something other than a CMU finish for your wall in your apartment, right? So we'll frame out some other kind of wall, but maybe we need to tie back to that CMU block wall because that's structural wall. We need to tie back to it, just support it so we can use lighter gauge studs, thinner studs, these kinds of things. So we can use an acoustically isolated L bracket. It's got a little rubber isolator in it to tie those studs to the CMU block. On the right, similar sort of situation, like say you've got kind of a strip mall situation, right, where you've got a bunch of different kind of tenants next to each other, and you've got a wall that already exists that's pre-built between two different tenant spaces. That's often a fire-rated wall, but usually not that great for acoustics. Typically, a new tenant moving into a space doesn't want to touch that existing wall. You want to build something outside of it. And again, you want to use thinner studs, this kind of thing, but maybe it's a fairly tall wall, so you want to tie back to the structural wall, but you want to maintain acoustical performance. So you can use an isolated L bracket to give you that kind of structural tie back, but still maintain your acoustic isolation. So you've got better sound isolation between these two spaces. Another situation where we kind of run into this like structural kind of connection path as an issue is shear walls. So again, I'm here in Portland, Oregon area. You can see my screen. There's Mount Hood back behind me. Not a real view, but it is my picture. So we're in a seismic zone. We're in the Pacific Northwest. So a lot of the multifamily projects I worked on, we had lots of shear panels in them, and a lot of times we would have double shear panels where there's a OSB or plywood shear panel on both sides of the wall. And for them to work effectively as shear panels, as best I understand it, they need to be tied directly to the studs, to the structure, right, to keep that structure from racking, in the event of an earthquake. So that limits our abilities for acoustic isolation because typically we want to have these sort of continuous membrane layers. Usually it's a drywall. We want to have that decoupled from the studs. But here you see a series of test data where we go from just a base shear wall there on the left, so just the OSB or plywood attached directly to the studs. And then we work through kind of adding things to it. So we add some drywall, then we add clips and hat channel and then drywall. And in this case, you see that we get an improvement from adding the clips and the hat channel. This is the middle wall there, third one from the left. But we don't have any insulation in the cavity between the drywall and the plywood there. And so while we get an improvement in our STC rating, it's still not that great. And we've created this little trapped kind of airspace that'll transmit, the air acts as a spring. And so it'll transmit the vibration, the sound energy from the drywall to the plywood and then through the rest of the structure. We get this kind of buildup of sound in this constrained space. If we put insulation in that cavity, you see we get a 6-point STC improvement, and now we get a wall that performs above code. So we've got this acoustic decoupling, but we've also sort of taken care of this cavity path by putting the insulation in there. And just for comparison there on the right, I have a similar wall, not the same test series, so not an ideal comparison. It's a 2x6 wall instead of the 2x4s on the other, but you can see it's another double shear wall, but we've just put resilient channel over it. And that only gets an STC 40. So we don't get enough decoupling there with the resilient channel because it's such a small airspace. That air just acts as a spring and transmits that energy through. So you really need a bigger separation between your drywall and your shear layer. All right, now cavity and structural paths. And I think I'm doing all right on time here. I've got some of these. I'll try and be fairly succinct and then have some time for questions, I think. So, all right, so first one is like door and window jams. So this is if you've got specifically like a clip wall. So, doors and your windows are often like a penetration in your wall. Say maybe you've got like an STC 55 wall, you probably don't have an STC 55 door or window. If you're designing a recording studio or something like that, like, yeah, you probably should have an STC 55 door or window itself. But typically, you know, exterior facade of a building like overlooking a highway or something like that. Maybe we'll go for a higher performing wall, and we'll try and minimize the size of our windows, which often, you know, we're at odds with daylighting requirements and just views and all these kinds of things. So there's a push and pull there. But you know, we try and minimize the size of the windows because, you know, getting highly acoustical performing windows is very expensive. But then we still have, you know, maybe we have clips and hat channel for our walls. We need to figure out that interface to the door or the window. Or maybe we've got, you know, an apartment corridor wall where we've got clips on it because there's a, you know, there's a bedroom there that abuts the corridor, but then we also have our entry door. So door head and jams, the trick here is, you know, with clips and hatch channel, again, you've offset that drywall further from your structure. So typically about 1 5/8 gap, something like that. And so you need to have this little drywall return. You can see it there on the left for the head, and then on the right for the jam. You need this little drywall return, so you can have some L angle there that's attached to the hat channel that supports that return of your drywall, and then you use acoustical sealant in a bunch of different places to make sure there's no gaps. And you make sure that the drywall return that's supported by the L angle has a gap between its end and the structure. So again, you don't get a rigid structural path there. And then you put a bunch of acoustical sealant in here to make sure you don't have any gaps to address that cavity path. Similar sort of thing for window head and jams, except oftentimes, you know, your window might be pushed out to the far outside of your building envelope or something like that. So you've got a bigger return. So sometimes you can still do it the way I've shown, where you've got L angle. Maybe you just use a bigger L angle with a longer leg on it to support that drywall. But if that, you know, the sort of cantilever of this drywall return to go from, you know, face of your drywall back to your window, if that starts to get too long, it's not going to work. It's not going to support that edge well. And so you have to maybe support that drywall off of the structure and then create a gap there. And that's kind of what we've done at the window sill, because the sill itself is especially tricky because it's something that's going to have probably load on it, whether it's just people putting some plants in their window, or it's, you know, my kids climbing up in the windowsill or whatever to get a better view outside, something like that. So here you add some blocking to support that sill and bring it out further, bring that support out to the drywall that's there at the wall. This is creating sort of a rigid structural path through here, so not ideal, but again, we also have a weak spot probably already at the window, so matters a little bit less. We just want to make sure that we don't compromise the performance of the rest of the wall. So we make sure that that drywall there that's supported by the clips and hat channel is still kind of free floating, but still sealed, but with flexible acoustical sealant. All right, intersections. So wall-to-wall intersections. So in these, with these intersections, and really with all of this kind of stuff too, right? We're talking about acoustics, but there's also a lot of other design considerations that come into play here. You know, just kind of constructability, parts and pieces, how they go together, but also fire is really important in these. So for a wall-wall intersection, kind of the way you do this and how you treat it, and wood is pretty similar for non-rated to or a rated intersection. So on the left, we've got a non-rated, say this is an interior partition, like maybe between bedrooms in an apartment. So non-rated wall intersecting a rated wall, maybe like the apartment to the corridor, something like that. So we want to make sure that we don't have continuous paths and these kinds of things. So in this case, you know, there are some tricks here. So we've got this wood blocking, and here actually we do have a continuous path like this, as you can see through this wood blocking into here. Now, there's a lot of sort of discontinuities in this path. It could work. You could maintain, try to keep a gap here, but that gets tricky for fire. If you have a gap here because your drywall is discontinuous, you can intersect your drywall with wood blocking because it counts as fire blocking. So you want to kind of pay attention to this detail here. If this is a rated wall, then we need this fire blocking both for this path and for this path. So you kind of have to have this sort of like beefed up 3-stud corner here. But we make sure that there's a gap here, there's a gap here. We've got acoustic isolation and resilient channel here and here. So you just kind of, you want to just start taking your pencil or your mouse and really kind of just tracing all of these different paths through here and make sure that you've minimized the sort of rigid structural paths. And if you do have some kind of rigid structural path, it's as long and circuitous as is possible. And then make sure you've sealed all of these gaps too. So anywhere where you've created sort of a discontinuity, a gap, make sure you've got acoustical sealant sort of specified for that. And these can get complicated, and this is why it's always great to, bring in an acoustician. And I think it's great to have them help select wall assemblies with the right STC ratings and things, but it's really key to have them dig into all of these details, like go through your detail sheets and kind of do this exercise of tracing all these potential, transmission paths and trying to optimize these, but of course, taking into consideration, construction, constructability, cost, fire, all of these other things. So similar kind of thing for a wall-wall intersection in steel, except that you can't use steel studs as fire blocking. So if you've got a non-rated thing, you can't interrupt the drywall, which then means you have this continuous path here. Now, if it's from, a bedroom to a bedroom in an apartment, maybe it doesn't matter as much. But if, say, it's, that sort of like strip mall, two separate tenant kind of things, and this is a medical office space, or this is, an express clinic or something like that, right? And here's one patient exam room and here's another patient exam room. Well, we definitely want acoustical separation between them, but maybe this is not a fire rated wall, but this is a fire rated wall between this tenant and a separate tenant. So here we have this continuous path. Maybe you want to break the drywall here, but then use fire and acoustical caulk to seal it, almost kind of like a control joint. Kind of treat this that way. If you have a rated wall intersecting a rated wall, you can break it like this and make sure you've got, little gaps here. This stud actually isn't touching this drywall, but we've got sealant here, and we've got sealant here again. So again, you're just kind of tracing all these different paths through. Similar sort of thing for wall to ceiling intersection. Again, here in wood, we can use the top plate as fire blocking, so we can interrupt the drywall. And now here we've got a rigid connection, but here we've got isolation at the top. In this case, our gypsum concrete has an isolation mat underneath it. So we do have some acoustic separation here for this path going through. Typically, especially if this is like on the right, we've got a demising wall here. This is, maybe, I guess as it's drawn, maybe this isn't quite load bearing, but oftentimes if the joists are running the other direction, this could be a load bearing wall. So you can't put some acoustic isolation here. So you have these structural limitations on what you can do. So again, having this isolation at the top side can be helpful. You could also put acoustic isolation on both sides of the wall if you're going for very high levels of performance. Again, this is a thing to get an acoustician involved in to look through all these details. In steel and concrete construction, oftentimes the steel studs are non-load bearing, so then we can put acoustic isolation here at the top. I talked about this in the deflection track, but if you don't have deflection track, this is simpler. And so you can have an acoustic isolator here, a rubber isolator. Make sure you have acoustical sealant here. Typically put some fiberglass in here to help kind of fill in this gap as well around your isolators. So you create this sort of acoustic separation between your structure here and your wall. Wall to floor, sort of order of operations, and there's a lot of different things that go into the consideration of, order of operations of, do you, frame it first and then do your gypsum concrete and then come back in and put in your drywall, or all these different things. So, and different people, different regions are going to have different preferences for how they do this. But the thing that you need to pay attention to is making sure that things that are supposed to be acoustically isolated stay acoustically isolated. So in this case, we've got a gypsum concrete topping that's on a mat. That needs to stay isolated from the subfloor and from the bottom plate, right? So you need to have this perimeter isolation strip or something that comes up here. But you also want to make sure that your gypsum board, your drywall, is separated from your gypsum concrete topping. There was a project way back in our history where we got a call because people were saying like our wall wasn't working, and we said, well, tear the drywall out and send us some pictures, and so we can see what's going on. and they call back and they're like, well, we can't get the drywall out. What? They had the drywall installed already and poured the gypsum concrete, and the gypsum concrete had bound to the bottom of the drywall and then gone over and made contact with the top plate or the bottom plate of the wall. So you had this rigid connection through here, and also it was binding up the drywall that was supposed to be isolated. So you need to pay attention to these different things and these details and figure out, like, if you're going to install your drywall first, how are you going to make sure that you don't get rigid connection between your gypsum concrete and your drywall? And there's different ways that you can do that. Just, perimeter isolation strip is kind of the best place to start. Perimeter isolation strip is usually just, like 1/4 inch thick foam tape, basically, but there's a lot of different options for it. Another thing that you can do is you can isolate your bottom plate, same way we isolate the top plate. This is maybe less common, but you'll see this in high-end construction. So, high-rise condos, we'll see this in New York in really high-end condos where they're trying to get very high levels of sound isolation. You might isolate a wall like this. Also, recording studios or those kinds of like high-end performance spaces where you're really trying to create like, this room that's completely isolated from all of the other structure and things around it. You can isolate the walls here. Again, this is just some rubber isolators, an acoustic isolator that separates that space there. Window mullions. So window mullions are a really tricky one because you have sort of often weak cavity paths and weak structural paths. So let's see, I think I've got some arrows in here. So you have this cavity path, right? So, oftentimes, you'll have your sort of continuous curtain wall and your interior drywall partition, like say this is between two, condos, something like that, right? Will stop, but it'll stop a little shy of this just because of construction tolerances, gaps, and all these different kinds of things, right? And so you'll have a little gap here. And you'll see this, or like, again, hospitals and things like that. Oftentimes, if you go and you walk over to the window and you look, you can see, and you'll see light coming through, and you can just totally have a conversation right through that gap. But even if you just were to seal that gap, that helps, but you still also have the structural path through the window mullion. I mean, this is 2 layers of drywall on either side of this wall, right? That's, 4.5 pounds per square foot on either side of this, right? You have a lot less mass than that in a typical sort of like aluminum window mullion. So you've got this weak structural path too. So one way to do that is to add on some sort of substantial structure. And so in this case, we've got another custom aluminum section, and then we've got mass loaded vinyl in here. So to add mass, but then this entire assembly that's giving us our mass is also acoustically isolated using the same kind of rubber isolator, acoustically isolated from this. So we're adding mass, we're sealing it, right? And we're addressing that structural transmission path. This can be tricky to do. This is often not a retrofit sort of an application. This is a new construction application where you're coordinating with the curtain wall manufacturer to help manufacture these pieces. The other option for a retrofit situation is to just stick in something that creates a good seal that also adds some mass to it. So there's acoustical mullion seals, which is like a coated foam, and you can put those in there and it helps seal this up, but also adds some mass. And there's some test data for that. So oftentimes the way you'll kind of test a lot of these things is you kind of do an A/B test. So you test a base wall. In this case, we had a single stud wall with 2 layers of drywall on either side, and they put this, I think it was like a 2-inch gap in here. So there's just like a whole opening right to the middle of the wall. And then for the baseline test, they sealed it up with 2 layers of drywall. So you basically have a continuous 2 layers of drywall on either side. And then to test this mullion seal, they pulled these drywall caps off and they put your mullion seals in. And you can see here, there is a bit of a drop at 3 SDC points, but you're still maintaining above code minimum performance. And you can kind of go through, again, get an acoustician to kind of come through and do the analysis on this. All right. I think that is it, and we've got a few minutes for questions. So I think I saw some questions and comments popping in. We'll go through that, and yeah, take it away, Steve.
Okay, thanks, Mike. Not a lot of questions. One of the most common here was, will a recording of this presentation be made available? Yes, to everybody. We will have a copy, a recording of this presentation available to all the attendees. We did have one question from Matt Tapey, and this was regarding the detail where you showed gypcrete. We were talking about the encapsulating the drywall in the gypcrete and how that created a problem. Matt's question was, do you have a detail with the perimeter isolation tape installed against the drywall and then the gypcrete poured against that?
I don't think I have one that I could just bring up right now, but it's basically that is you run your drywall down. You want to make sure that you seal the drywall, so you use acoustical sealant, and often these are fire rated ones too, so a fire rated and acoustical sealant. And the thing that's special about acoustical sealant is that it's, at least in theory, it is non-hardening, so it won't over time solidify and create a rigid connection, because for acoustics we want, we're trying to again keep these things structurally separate, so we don't have this rigid transmission path. So acoustical sealant will stay a little bit squishy, resilient. So you would have your drywall come down to your subfloor, probably in this case, and you'd have acoustical sealant there to seal that gap. And then you would have your acoustical isolation membrane that's going to go underneath your gypsum concrete, and then you would either wrap that up or have perimeter isolation tape that comes down, and maybe have some tape in that corner or something like that. Exactly how you do that, that's really something to reach out to the gypsum concrete manufacturer, because they'll have some specific details on what that is. You basically want to create a bathtub for your gypsum concrete to pour it into. And do that. You also want to make sure that you have, clips and hat channel down very close to the bottom of the wall, or resilient channel to support that drywall, both to make sure that you've got something to attach, maybe base trim to, but also to support that bottom edge of the drywall. So when the gypsum concrete's there, it doesn't kind of start getting pushed in.
All right, thank you, Mike. Next question comes from Uli Brandstetter. Can you provide a spec for the acoustical mullion seal that is preferred in retrofitting existing curtain walls these days?
Yeah, let me go find that real fast. Or Mike Gernhardt, if you're here, do you have that up that you can put in the chat? This being an AIA accredited presentation, right? I'm not mentioning product names or anything like that. But now that we're outside that portion, so the mullion seal is the PAC AMS for acoustical mullion seal. I've got a link to our page. I think if I put this in the chat, everybody can see it, right?
Yeah, they should be able to. Mm-hmm.
So, or you can just go to pacinternationalllc.com, and in the search bar up at the top right, search acoustical mullion seal. Actually, let me just share this screen. So you can see this here. So it's a foam, and then it's got a silicone coating on it. You can do it coated on 2 sides or 3 sides. This comes in, I think it's 2 meter and 3 meter lengths, and then there's a bunch of different like depths and sizes for the foam that you can get for different gap sizes and things like that. And we can help you select the right size and everything like that for whatever gap you have. These are pretty easy to cut. I mean, you can cut it with I don't know what exactly the recommended cutting thing is, but like you cut it with a steak knife or just a box cutter or something like that. You talk to Mike Gernhardt, he can give you better instructions on how to actually cut the thing where you get a nice cleaner cut. But it's really easy to cut to length, and then you basically just press it in and squeeze it in, and that's about it. So it works well. It's a quick, easy retrofit. If you've got, medical office buildings or something like that, this is the kind of thing where, overnight when the building is closed, like even the maintenance staff could come in and kind of install these and get a huge improvement in speech privacy between, patient exam rooms, something like that.
All right, thank you, Mike. Ken asks, can you touch on virtues of isolation versus constrained layer damping for transfer of energy?
Okay, sure. So, how do I do this succinctly? So, like So within acoustics, we have all of these different tools. We have like acoustic isolation, we have damping, we have mass, all of these different things. We have insulation, in terms of like fiberglass or these kinds of things. And they're all different tools that we have to use, and they all do sort of different things, right? So isolation reduces the transmission of sound from one side to the other, right? Because it allows this thing to move without making this thing move. Constrained layer damping is really when you have these two layers, typically two layers of drywall next to each other, kind of moving sort of, in a microscopically, like moving kind of relative to each other. The constrained layer damping resists that motion and takes some of that motion and transforms it to heat. So it takes some energy out of that movement. Typically, the constrained layer damping materials like the engineered drywall or the goo that you can put between two layers of drywall, that tends to work best at high frequencies. It doesn't do much for like mid and low frequencies. So if you're primarily concerned about speech privacy, like say like between medical exam rooms, constrained layer damping can work well, and it might be all you need to, plus some additional mass, making sure you seal and take care of all the details I just spent the last 45 minutes or whatever talking about. But the constrained layer damping might be enough to kind of get that transmission where you want it. However, if you're concerned with speech privacy, but also low frequency sound isolation, like between, hotel rooms or condos or something like that, apartments where you might have, you're going to have a home theater system, or even, a little Bluetooth speaker these days can put out quite a bit of low frequency energy. The constrained layer damping tends to not give you that much improvement down at low frequencies, whereas acoustic isolation, like the sound isolation clips, the RISC 1, the PAC RSIC-1, will also give you big improvements down at low frequencies. And so you get this broader range of improved acoustical performance. Yeah, hopefully that's helpful.
Okay, thanks, Mike. Let's see, doesn't look like there's any other questions. There was a question from John Creighton. Are there any peel and stick acoustic seals for small areas around gypsum wallboard where it would be hard to use a caulking gun? Yes, there are. There are perimeter isolation tapes. I don't know if you want to expand on that, Mike.
But that's perimeter isolation tape's not a seal necessarily. Perimeter isolation tape is sort of a decoupling thing, but it's often
fair point
foam, and so like, oftentimes like if we're doing a spring isolated ceiling and we've got drywall for the ceiling abutting drywall for the wall, we'll put perimeter isolation tape just to create a gap between, to make sure that there's a gap between the ceiling drywall and the wall drywall. But then we come back and seal over that with acoustical sealant, because that actually has the mass to actually seal the thing. But peel and stick, I don't know. It's not something that like I can think of any that come to mind. There are, in the world of fire, there are a lot more kind of new products coming out for fire seals that are kind of like a peel and stick sort of thing. But oftentimes those are an intumescent, which will expand when it's exposed to heat. And so normally there's still a gap there. But when a fire happens, the intumescent will expand and seal that gap. But for acoustics, we want that gap to be sealed all of the time, not just when there's a fire. Because when there's a fire, we don't really care as much about sound transmission. We've got other more important things to worry about. So if you see like a peel and stick seal, but it's one just for fire, I wouldn't necessarily assume that that's going to work for acoustics. So potentially, but if you're looking for something like that, I would look for some of the companies like STI, I think is, what is it, Special Technologies or something like that, that does a bunch of fire sealants and things. Look to some of those and see if they have something, but see if you can get actual acoustical test data for it, and not just like they put up a number that's like, this is an SDC 55, but an actual acoustical test report, and then see if they've done like back-to-back A/B comparison, like what I showed for the acoustical mullion seal, where they tested like the base wall and then they put a gap in it and then they put the seal in there. Like that's the ideal way to do a test like that and see if a sealant actually works well.
All right, thank you, Mike. Doesn't look like there's any other questions. unless I missed any here. I don't think I did. Mark Schlomp did ask if is there available a guide specification for family products on your website? And Mark, yes, I had mentioned I was going to cut and paste our registration link to our selector tool, assembly selector tools on the website, and I will put that in the chat. So to everybody who's here, if you're interested in looking up assemblies, looking up fire rated assemblies, or looking for specific STC performance ratings on a particular type of assembly, the link I just put in the chat will allow you to register for our website. Mike approves those registrations. We kind of like to keep it behind a firewall so that our competitors can't go in there and take all of our data. So fill out that registration. We'll get you approved, and you can access all of the tools and resources that are available on the website.
Yeah. So, and since I've got my screen shared, so there's a product search. You can go sort of sort and filter by product group. And we've got kind of construction types where it's used these different kinds of things. And then over here, these links will take you to the product webpage. We also have our UL list and fire rating selector. This one does not require registration. You can go access this. And so, you can sort of by like system design type, all these different kinds of things, but you can also type in like L570, typical 1 hour wood eye joist assembly, and find these, and then you can see what pack products go in it. The one that does require the registration is the assembly selectors, the acoustical assembly selectors. And once it loads, you can come in here. You can kind of filter by fire ratings, STC ratings, these kinds of things, and then by structure type too. So say you want a steel wall and you want, 20 gauge, 33 mil structural steel studs, and you want a minimum of STC 55. Well, here's your different options that you can look at. And we have a whole bunch of different test data in here and things like this. Notice that I think the default is it only showed 10 entries. You can come up here and do this and get more. So more entries per page.
Yeah. Keep in mind on that too, if you put in certain criteria and don't get a result, that just means we don't have a third-party laboratory tested assembly that we shared. But give us a call.
Or we have one and I haven't gotten around to putting it in there yet.
That could be
That's always possible. So
so give us a call if you can't find what you're looking for, and we'll help you out.
Yep.
All right. I think, let's see. Looks like there's no other questions at this point. We could stay on for a few more minutes if people have other questions.
Yeah, and just a note, so this was part 1, walls. Next month, in about a month, you'll see an email for all of you that attended. You'll get a thank you email with a link to the recording of this when it's up. And then also in that, I think we'll have the link to register for next month's, which will be on ceilings. So we'll talk about things like soffits and lights, can lights and ceilings, and fire sprinklers, which there's really not anything good you can do for fire sprinklers, but we'll talk about a bunch of different ceiling details. We'll talk about spring hung ceilings, clip ceilings, all these different kinds of things. And we'll put all of that. Also, there's been people asking about, do you have a detail for this or that or whatever? We are working on putting together a detail library that'll be 2D and some 3D like Revit and CAD details. So we're in the process of working on that, and eventually that'll be another sort of database like we have here. We'll probably require, I don't know if we'll require registration for that one or not, but if we do, it'll be the same registration if you've already got access to our acoustical assembly selectors. So stay tuned for that. Maybe we'll have it ready to roll out next month when we give the ceilings presentation.
All right, thank you, Mike. We'll stay on for a couple more minutes here for any other additional questions. See a lot of thank yous, so thank you for attending today. Make sure you get us your email address and an AIA number. You can send that to support@pac-intl.com so we can make sure we get your credits recorded.
Yeah, thanks everybody so much for attending. I really appreciate it. And we're for the foreseeable future, we're doing these on a monthly basis, so stay tuned for other ones. And if you have any particular topics you would like me to cover, shoot us an email, let us know. do keep in mind it needs to stay within the sort of realm of sound isolation, wall, ceiling assemblies, that kind of thing. It needs to stay within purview of pack products. I'm not going to talk about like interior room acoustics treatments and stuff like that. Pack doesn't do that, and I don't do that anymore. I used to as a consultant, but I'm not the expert on that. There's better people to give you advice on those kinds of things. But if you have ideas for topics on sound isolation, these kinds of things that you'd like us to address, shoot us an email and we'll take a look at it.
Phil asks, where do we get HSW credits?
So HSW credits. So this presentation is registered with AIA for a 1 hour, like 1 credit, and it counts as an HSW credit. And I'm pretty sure that we ran the registration for this through AEC. So if you put in your email address and your AIA number when you registered for this, then that should all automatically get taken care of. If you didn't put in your AIA number and email, then give us your AIA number so that we can keep track of that.
Yeah, again, send that to support@pac-intl.com, and we'll make sure we get that recorded for you.
And I see Mark said, thank you, good presentation. Still looking for specifications. So if you go to our website, or Mark, you're welcome to just send me an email directly, and we can kind of set up a meeting or talk more through stuff. My email is mraley, MRALEY, at pac-intl.com. Sorry, I had a brain fart there for a second. But if you come and you look at, any of our products here, I'll just kind of show you an example. Look at our RISC one, for instance. We have the submittal docs. So there's a whole submittal package that includes specifications, installation guides, a product data sheet, all of those kinds of things. But then we also do have product guide specification for these. And we are in the process of updating our specs. I have been negligent in doing that, but we are in the process of doing that, and we'll hopefully have that wrapped up this year. But we do have specs for a lot of our products already on the webpage, so you can go grab those.
All right, thank you, Mike. Looks like no other questions at this point. We could stay on for another minute or two, or if not, certainly if you have specific project questions, certainly you can email us. You can send to support@pac-intl.com, and be more than happy to do a quick consultation on your project or answer your questions that way. So.
Oh, and I still it was Neil Shaw that asked for source for the custom AI section.
Yeah, and I'm not sure, Neil, what you were referring to by custom AI.
Yeah, Neil, send me an email. What were you talking about for custom AI? We can. I don't have any custom AI stuff, but
Oh, AI aluminum.
Oh, custom
aluminum.
Oh yeah. Thanks. That's AL aluminum. Thanks, Neil. Right. The custom aluminum. Okay, so that was for the mullion, the window mullion that I showed. So that was with Oh, you know what, Neil? I think it was Mark Bastash that not Mark Bastash. I think Mike's off doing other things. I am having a total brain fart. Anyways, it was another acoustician, Neil, who I'm sure you know. I'll think of his name as soon as I get off of this, and I'll send you an email. That was a project that PAC did many years ago, and we worked with Benson Industries on that project. I think it was LA Live was the project, but we worked with Benson Industries, which was the curtain wall manufacturer. So the way to do that is often to work with the curtain wall manufacturer to create that, and that's part of that is, I mean, one, they have the skills and resources and everything like that to fabricate those custom, aluminum pieces and things like that. But also they can do it in a way that exactly matches the color and the finish of the window mullions, like the primary window mullions. So everything looks factory. It all looks good. We have looked into, Elzo went looking for a long time trying to figure out how to do that, how we could do it in-house. And just it's all so custom and bespoke that trying to do it in a way that matched and all that kind of stuff just didn't make sense for us. But we're happy to work with you on a project and work with, curtain wall manufacturers or other people involved in the project to try and help put that system together.
All right. Thank you, Mike.
Guess it's not all about AI yet, Steve.
The buzzword.
I know.
Yeah.
I was like, custom AI section. I don't know. I'm trying to mess with AI to do some calculations for me, but yeah. All right. Well, I think let's call it. Thank you everybody that's
Yep.
still sticking
Thank you
around.
so much.
Thank you so much. Hope you have a great day. And yeah, if you have any questions, feel free to reach out to us. We're always happy to help. Always happy to kind of talk through all of these details and
Absolutely.
things like that. So
Have a great day, everybody.